get here.
Whoa! Oh! Where are we?
What are you doing here?
Whoa, dang!
Where's my clothes?
Francis? Whoa. Where's Ben?
Ben? Ben! Who cares? What are we doing here?
Why am I thinking about a landfill?
Landfill?
Oh, problem number 5. At the beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. Planners estimated that W will satisfy the differential equation dW dt, and 1/25 times the quantity of W minus 300 for the next 20 years. W is measured in tons, and T is measured in the years from the start of 2010.
What did you say? What?
What?
What the heck was that? Let's go find Ben.
Oh. Woo! I found Ben!
Part A. Use a line tangent to the graph of W at t equals 0 to approximate the amount of solid waste the landfill contains at the first 3 months of 2010. Time equals 1/4. We're going to use the equation of the tangent line to estimate the amount of solid waste the landfill has at the end of the first 3 months of 2010. Remember that a tangent line is a derivative, and we already have the derivative of W with respect to time. We're going to use the point slope equation to find the equation of our tangent line. Don't forget your initial conditions. We still need to solve for m. Remember this equation. M is our slope, and a slope is a derivative. We're going to plug the y value into our derivative. Now we're going to solve. Don't forget to simplify. Now we have our slope, m equals 44. Do you remember that equation? Here's that equation. Let's plug in our slope and simplify. We can simplify even more. We have the equation to our tangent line. Now let's plug in 1/4 into our tangent line equation. Y equals 1,411, meaning at the end of the first 3 months of 2010, there will be 1,411 tons of solid waste in the dump.
Dude, you got dirt stuck on your chest. That's not dirt, that's a tattoo. It's dirt. Enriquez? Who's that? Yun?
That's my last name, duh.
Yun?
Why do you have a K on your arm?
What are you talking about? This? That's not a K. That has an arrow.
Cupid was here!
Cupid? K for Cupid?
Yeah!
K for fun? K for concavity. Part B. Find the second derivative in terms of W. Use the second derivative to determine whether your answer in Part A is an underestimate or an overestimate amount of the solid waste that the landfill contains at time t equals 1/4.
The problem asks you to find the second derivative of W in order to determine if Part A was an underestimate or an overestimate.
Okay, so let's break it down into 2 parts. Time for Part 1. Find the second derivative using dy dx format. So now this becomes this. Now we distribute. And now derive using implicit differentiation. We're almost done. Just change back to dw dt. And that is our second derivative. Whew, but we're not done yet. Part 2. Figure out if A was an over or under approximation. Of course, substitute. Now distribute and plug in the rest. So after we simplify, our answer yields a positive value, meaning it's concave up and also an under approximation.
Your hair's dirty.
My hair's not dirty!
Okay, then why does it have a feather here?
I don't know.
And you have a shoe on your back.
I have a shoe?
It smells like the church where you took the AP test.
The AP test? What?
And it says something about a particular solution.
Particular solution? Woo! Part C!
WT to the differential equation dW dt equals 120 times the quantity W minus 300 with the initial condition W of 0 equals 1400.
So the problem asks us to find the particular solution W equals W of t to the differential equation with the initial condition of 1400. But let's break down this problem and save the initial condition for later. The problem asks for a particular solution which implies implicit differentiation. So let's separate the variables. Now that the variables are separated, we can integrate. Remember, don't forget the c. Ew, there are natural logs. Let's get rid of that. Exponentiate, exponentiate. Okay, we're almost done, and I'm gonna need a little room here. With the exponent rule, you want to expand the e to make it easier. Now you want to remove the absolute value signs. And since plus or minus e to the c is just a constant, you can substitute it for the new variable a. Now all you gotta do is solve for w. And there is your solution. However, the problem asks for the particular solution, which is where the initial condition comes in. Use the initial condition to substitute for w and t in order to find a. Then plug it in, then voila, the particular solution.
Okay, so we have all these questions answered about a landfill, but why are we at the beach?
Why are we at the beach? Wait!
We must have been taking the AP Calc test! You're right! And we came here like stand and deliver.
But I think we were just too brain dead to even remember.
Hey guys, I found my phone, and you don't want to see the pictures that are in here.
Whoa!
With my swagger, hop in there with Joe, I got places to go. People to see, time is precious. I look at my Cartier out of control. Just like my mind where I'm going, the women, the shorties know nothing but clothes. No stopping at my Pirelli's on. Unlike my jewelry that's always on. I know the storm is coming, my pockets keep telling me it's gonna shower. Call up my homies, it's on and pop.